So I need to implement the same thing, whatever we have covered for single linked list. Same thing I want to implement for double linked list also. Let us implement all these methods related to the double linked list. Sir, here, see, double linked list means what? We have two types of what you can call nodes will be there. Okay, like in single linked list, how we have represented the node, if you remembered. So we have taken node in this style. Okay, we have only two fields will be there. So this first field is called as, so this first field is called as a data field, and this one second field is called as next field. Okay, this one is called as a data field, and this one is called as next field, which is pointing to the next node. Sir, the same style will be there even for double linked list also. Okay, but in addition to that, we will have one more node here. So I think you people know very well about this node. Can you please tell me what is the name of this node, sir? Everyone, can you please, what is the name of this node? Yes, very good. It is nothing but a previous field. Okay, so we will have previous field. So here, at the time of insertion, at the time of new node creation only, you have to concentrate on this. Okay, when you are performing insert operation and when you are performing delete operation, you have to concentrate about this new link. Except that, rest of the programs, rest of the method implementation will become same. Okay, anyway, one by one I will explain with the help of program. Have a look once. Okay, so anyway, main method is there here. So what is the program that we have to take? A class DLL, double linked list. So what fields are there in the double linked list? First, I am going to take one special pointer called head, that is nothing but beginning of the node, and integer size is equal to 0. Like this we have. So integer size is equal to 0. Okay, initially how many elements are there? 0 elements are there, and I am taking class node. So this node will have three fields. One is nothing but data, next field, okay, next field, and then node previous field. Three fields are there. So whenever we are creating a node, I am going to send data for these three fields. So this dot data will become data, and this dot next will become next, and this dot previous will become previous node. Like this we have. And whenever a new node got created, I am incrementing the size. That's all. This is nothing but if you want to create a new node, how we are going to create. Okay. Now void, I want to take one more method called traverse. Okay. Otherwise print. Okay. Void traverse. Let me take official name. So traverse, which is used to print that list. So we know very well, if head is equal to null, there is no more elements in this linked list. So we are going to print the message saying list is empty. Okay, then we have to terminate. Otherwise what we are doing, as usual, same code, whatever we have implemented for single linked list, same. So current node I am taking. Okay, current node will become head. Okay, then while current node, okay, while current node is not equal to null, so what we have to do, system dot out dot println of, I will take only print. So current node dot data. Okay, then next node will be there. Like this I am taking. Then so current node will become, so current node dot next. Like this I have to take. Okay, so this is nothing but just like a normal display function only. At last I am going to take null. Now sir, let me create one simple object, double linked list. List is equal to, so new double linked list. So list dot I am going to use traverse function. Let us execute up to this and see what happens. Now you can see the list is empty. Now my requirement is I want to add the objects one by one. We know very well about the methods. So I want to add, okay, but okay, let it be. So I will explain this function first of all. That is a traverse function, how it is going to work. Okay. So what is the logic that we have taken? Node, current node. This is the logic, right? I will explain here itself. This is nothing but what we have. Now listen carefully, sir, how it is going to work. Consider I have a linked list is there. Okay, I have a linked list is there, double linked list. So how many nodes are there? Consider initially I have some 3 elements are there. I want to print these elements content. So this is nothing but a second node. This is nothing but a third node what we have. So this pointer is nothing but null, and this pointer is nothing but null. Its content is 11, its content is 22, and its content is 33. Like this we have. So this field next is nothing but this one. Okay, so this node next field is nothing but this one, and this node previous field is nothing but this one. Like this. So how many pointers they are going to maintain? 2 pointers. This next node is nothing but this one. Okay, and this one previous field is nothing but this one. Like this we have. Okay, so what is the name of this field? This field name will become so head node. Okay, this field name is nothing but head node. This is nothing but, so head node what we have, I am representing it as head. Okay, now sir, what is the logic that we have implemented? Current node is equal to head. So this node will become which node, sir? Current node. Sir, is it not equal to null? Yes, it is not equal to null. Print the data. What is the data that we have? 11. Next arrow mark. What about next one? Current node is equal to, current node tends to next. Now this will become current node. So this will be gone. Okay. Sir, is it equal to null? No. Then current node data, which is nothing but 22. So what about next field? Current node is equal to current node tends to next. That means this will become your current node. This link will be gone. Sir, is it not equal to null? Yes, it is not equal to null. What is its data? 33. Then, so current node is equal to current tends to next. What is the next node? Sir, no node is there. So that's why current node will point to null. Here is there. Sir, current node is not equal to null. No, current node is null. So it will come out from this. If you observe here at the end, we have printed null. So it is going to print null. This is nothing but the output what we are getting for this. Okay. I think you people got very clear clarity how this double linked list display function is going to work. Can you please confirm everyone? Is it clear? Everyone, please confirm. Is it clear?
Yes, sir.
Right. Now, so next I want to add the objects. Okay. So we know first one, we have to take, sir, 1 second, please wait. Yeah, sorry for the delay, sir. One emergency call. Now let us go with, I want to implement a method which will take adding the elements at first, sir. So which is going to take the data. Okay, which is going to take the data. So we have to insert this. Sir, what is the logic? We have to create a new node. Okay, new node of I'm going to take the data. Next field will become null. Previous field is also will become null. So if size is equal to 0, that means if there is no element, then your head will become new node. Suppose if the data is there, here we have to write the situation. Very, very important. Please listen carefully. If the data is there, then what will be the situation? Now listen. So here, consider initially there is no data. Initially there is no data. That means where my head is pointing, sir, my head is pointing to null initially. Okay, my head is pointing to null initially. This is nothing but, so what we have at a very beginning. Okay, at very beginning, this is nothing but the situation. Now I want to insert a node. Okay, I want to insert a node at beginning, sir. Okay, let us see how you can insert. Now I want to insert node at very beginning, sir. Let us see how you can able to insert this. So first I am going to create a new node. Okay, so first I am going to create a new node. This is nothing but a new node what I have. Okay, so which is having two fields. Consider the data is nothing but something like 33. This is the node which I want to insert. So once if you create a new node, what will happen? Okay, so what will happen? It is going to labeled with new node. It is going to labeled with new node. Sir, this will become new node. This will become new node. Okay, what is the name of this field? It is nothing but a new node. So initially, sir, is size is equal to 0? Yes, because we don't have any element. Size will become 0. Now what will happen? Your head will become new node. So once if you create new node, previous field is null, next field is also null. So hence this one will become which node? Head node. Okay, so head node and this node both are pointing to the same. So that means, so single node got added. Sir, okay, fine. So that means we have a node is there. Okay, listen carefully. We have a node is there. This is nothing but node what we have. So here previous field is null, next field is also null. Okay, previous field is null, next field is also null, and the data is nothing but 33. Just for reference purpose we have used new node, but actually what is the name of this one? Which is nothing but head node. So head node is pointing to this one, sir. Like this we have. Now, sir, already one node got inserted. I need to create one more node now. So what will happen? Anyway, add first, right? It will be added here. Okay, so it will be added here. Now, a new node will be created, and this is nothing but fields what we have. Okay, so this is nothing but fields what we have. And sir, what about references? Previous field is null, next field is null. Consider the data is 22. So what is the name of this node? Definitely it will be new node. Definitely this name will be new node. Like this I have node is there. Okay, like this one node we have. Okay, one second. Hello, hello. So next node here we have pointing to this new node, sir. Okay, new node is pointing like this. Now what we have to do here? So what is our next requirement? We have to link this. So in our previous single linked list, directly we have linked, but here that is not the case. Okay, we have to maintain two links here. What is the first link? Sir, this head node previous will become new node and new node next will become head node. These two pointers we have to write. Sir, what are those two pointers? So head dot previous will become new node. Okay, this is one pointer, and new node dot next field will become head. Sir, after that anyway we know that head will become new node. Like this we have to write these three instructions. Okay, Sir, how the links are going to be changed? Now observe carefully. I am taking with the color. Head dot previous, which is head this one. So it's a previous node. Okay, it's a previous node is nothing but this one. So its previous node is nothing but this one. Okay, right? So what about the next one? New node tends to next. This is the new node, right? Next field is pointing to this head. Okay, like this we have. Sir, new node will become, head will become new node. Sir, this new node from now onwards, it will become head. Okay, from now onwards, so it will become head. Like this we have. Sir, what will be the updated list now? So updated list will become like this. Okay, updated list will become like this. So here we don't have this new node pointer. This will be gone. Okay, this will be gone. Like this we have, and this also will be gone. Like this we have, and this null is also will be removed, and this null also will be removed. That's all. This is nothing but what we have. So head is pointing to, okay, head is pointing to this particular node, sir. So I hope you people got very clear clarity how a new node will be inserted at the beginning. Sir, can you please confirm, do you have any doubts up to this? Everyone please confirm, any doubts up to this? So head dot previous will become new node. Okay, so new node dot next field will become head, and your head will become new node. Like this we have. Now I want to execute this code. Sir, initially the list is empty, so list dot add first of 333, list dot add first of 222. Okay, so list dot add first of 111. Like this we have. Let us execute this and cross check whether really those elements got added or not. You can see we are getting some null pointer exception. So because something is gone here, let us check what is that. 1 second, add first here. Next will become, so if head is equal to null, so where the problem is coming in line number 34. Yeah, here we have the problem. Head is equal to new node. So head previous node will become new node next will become head will become new node. Correct only, right? So if size is equal to 0, head will become new node. What is the problem here? Integer data null. Return statement is not required because we have written else, right? Hmm. One sec. Hmm. Size node data next previous data next previous. Spelling is correct only, right? Size plus plus. If head is equal to integer data, so node new node is equal to new node of data null. If size is equal to 0, head will become new node. Else, so head previous pointer will become new node next pointer will become head is equal to new node. Correct only. Now what is happening here? Add first. At least we will check by keeping these two as a comments. At least one node is adding. Null pointer exception cannot assign a field because this dot head is null. So head is not at all pointing. So we are missing that head field, right? So thing is problem. Here itself we are getting the issue. Here already head is there, right? Let us see first case what will happen. Let us trace out when we are adding the first node, this will become so head is there, so it is a new node, so content is 22. This will become next, yeah, null, and this is nothing but what we have. New node is equal to this one if size is equal to 0. Initially head is not there, so size will become 0. Then this one will become head. Okay, now I want to add one more node, so let it be 11. Even that first one item is also not getting added. 11, so let it be new node. So already head is there, its previous node is equal to new node. New node tends to next will become head node. Now head will become new node. Pointers are correct only. Something it is not assigned properly. If head is equal to null, list is empty. Head is equal to new node, size plus plus. Somewhere the problem is coming. I will do one thing, I will put this as a comment. Let us execute now at least. So it is displaying list is empty, correctly working. But when we are adding one element, it is not get added. Cannot assign a field previous because this dot head is null. This dot head is null. Head node is properly not pointing. That is the problem. Current node is equal to head. Head. First a new node will be created. Okay, suppose if size is equal to 0, that means
No, I think because we are creating the new node, So in the constructor, it will increment the size to 1. That's why head is equal to null because we haven't assigned it. So the new node has to be in the else statement or little bit later down.
Correct. Who is that?
Vishal, sir.
Yeah. Correct point.
So we can change the code by saying if head equals null instead of size equals 0. And then in else, we can put the node, new node.
Yeah, that is good. But I think we will do one thing. So here I will stop here and I will take this statement if size is equal to 0. So then we are going to create. So new node is equal to new node with this, and that will become here. Otherwise, so your new node will become like this. Let me check whether it is creating or not. Yeah, correct point, sir. Yeah, it is created. I think let me traverse, at least we are getting that 333 or not. Yes, perfect. Now let us work with this 222. Is it added at the beginning or not? Perfect. And now definitely it is going to work. So I think you people got a clarity. So how it is going to be added. The problem here is, sir, I have incremented size plus plus in this constructor. So when I am adding first, in the first line itself, I am creating a new node. So what will happen? Size will be incremented. If size is equal to 0, then only first node will be created. But this condition is false. Then it is trying to fetch the previous field of head. Head is null. So it is not possible, right? That is the problem what we are getting. Okay. Sir, then you can increment the size here itself means yes, we can do, but there are some future problems are there. That's why I have written the code in constructor. Sir, I hope why this kind of error came and how we have resolved this, it is very clear for you people. Thanks to Vishal. Can you please confirm everyone clear up to this? Clear up to this? Please confirm everyone. Okay. Right. Right. Sir, I want to add the element at last. Okay, I want to add the element at last. How you can able to do? For example, if this is my node, okay, if this is my node, then I want to add the element at the ending. I want to add the element at the ending. Sir, what we have to do? We have to create a new node here. Okay, so we have to create a new node here, and so this node will become new node. Previous field is null, next field is also null. So consider this is nothing but null, this is nothing but null. This value will become something like 55. And what is the name of this node? New node. Sir, what we have to do? So if head is equal to pointing to something, then you have to make it as a current node. Is current node is equal to null? No. Is next field is not equal to null? Yes. Move this current node to next one. Sir, is current node is not equal to null, next field is null. That means what? We have reached to the end. Now what we have to do? So this current node next field is nothing but new node. Current node next field is nothing but new node. New node previous field is nothing but current node. That's all right. So how you can able to write this code? Listen carefully. So first we have to take current node is equal to first node, that is nothing but head I am taking. Okay. So now next what we have to do? While so current node dot next term is not equal to null, until it is not equal to null. So what we have to do? So here your current node will become, okay, your current node will become, so current node dot next. Like this we have. Then at last, what is the current node next field? So current node next field will become your new node. Okay. Then your new node previous field will become your new node previous will become current. That's all. We have to insert this appropriately in our code, sir. Then automatically it is going to work. Anyway, I will explain this coding part later. Sir, I think you people got very clear clarity how physically it is going to work. Can you please confirm any doubt up to this? Okay, this is nothing but what we have. So to run the main program, we have taken this test class. So compulsory main method is required. I am taking public static void main and within bracket string array args. Anyway, our entire code we are going to run from here, and class double linked list is there. Listen carefully. So here we have to implement that double linked list concept, sir. Okay. So listen carefully how it. Sir, here what are the required things? First, I am going to take node head. Okay, node head. And what is the size value? Initially, size is equal to 0. And the class I am taking node. This node class contain data field. Okay, and the node next field we have, and then previous field also. And I am taking a constructor which is receiving these three parameters like data and the next field and then previous field. Like this, it is going to receive three fields. So current data will become data, and this data your next node is pointing to. So next whatever you have given, and this dot previous node is pointing to the previous. Like this I have given. So whenever a new object is created, a new node is created, I am incrementing size plus plus. This is nothing but node class what we have. And I think we have seen already display function, print function, like a traverse function we have seen. So if head is equal to null, that means if there is no head, then I am going to print. So system.out.println. So my list is empty. Okay. So my list is empty, something like this, and then I will return the content. So otherwise, what we have to do, I think after returning, no need to write any else. Directly we can take. So node, I am taking current node. Okay. My current node is always pointing to head. My current node is always pointing to head. So while your current node is not equal to null, if it is not equal to null, system.out.print of, I am taking, so current node dot data. Okay. Current node dot data I am taking. So next, and after that, we are going to give some arrow marks here to point to the next node. Like this I am taking. Then, so current node is equal to, so I am taking current node dot next, which is pointing to the next field. So after completion of this, just I want to print null pointer. That's all. Like this we have. So I think I explained already, same whatever we have seen in the single linked list, same concept. Now I will create one object for double linked list is equal to new double linked list. So initially I want to print the value. So I want to traverse the values. Okay. So I will call the method called traverse. Now I want to execute this. Just if you run, I think nothing is there, right? We are getting list is empty. So because we don't have any elements in the list, so my list became empty. Like this we have. Okay, sir, fine. Now my requirement is I want to implement one function called add first. So I want to add objects at very first location. Sir, it is going to take the data, which object you want to insert. Suppose consider here. So I want to insert list dot add first of. Consider I want to add something like 444. Okay. Then so list dot add first of. I want to take something like 333. Then list dot add first of. I want to take 322. Then list dot add first of. I want to take 111. So that my list will become 111. Next node is 222. Next node is 333. next node is 444, next node is nothing but null. So, but anyway, we have to implement this function first of all. Okay, let us see how it will be. Sir, very, very easy. Listen carefully. Sir, first I'm creating a new node. New node is equal to, so new node of data field, and the next field is null, previous field is also null. A node will be created in this state. Suppose if head is equal to null, that means what? If there is no any node, then your head node will become new node. Okay, your head node will become new node. Suppose if node is already there, then we have to use some three statements like head dot previous will become new node. Then so new node next field is nothing but a head pointer. Then your head pointer will become new node. Like this I am taking. Sir, first I will explain how it is going to work with the help of a small diagram. Have a look once. Listen carefully, friends. So here, assume my linked list is empty. I want to create a new list. This is nothing but new node what I have. Okay. So since it is a double linked list, we have two fields are there. Consider data is 444. Sir, is there any head node? No, your head is pointing to null. So your head is pointing to null. There is no node already. So if head is equal to null, yes, head is equal to null, then this node will become head node. Okay, this node will become head node. That's all. So this will become null, this will become null. Like this, we are going to get. Suppose consider already I have one head node is there. Okay, already I have one head node is there. Consider this is nothing but a head node. Okay, head node, the data is nothing but a 44. Previous field is null, next field is null. Now I want to add 33 at very beginning. Okay, this is nothing but 33 what we have. And what is the node this one? New node, right? This is nothing but new node. Sir, is head is equal to null? No. Then head tends to previous. Head tends to previous will become new node. This will be gone. Its previous is nothing but new. And the new node tends to next is equal to head. Anyway, this is already done. Now onwards, head is nothing but this one. Like this we have. Sir, consider already these two elements are there. This is nothing but null, and the next field is pointing to this one. Okay, this is null 44, and this previous node is nothing but this one, and this is 33. And what is the name of this node? Head. Like this we have. I want to insert one more. Consider it is nothing but new. Same algorithm. New node. Consider this data is 22. Previous will become null. Next will become null. Name of this node is nothing but new node. Sir, if head is equal to null, no, head is not equal to null. Head tends to previous will become new node. So head tends to previous will become new node. This will be gone. So new node tends to next will become head node. Then this will become head node. This will be gone. Okay, like this, a new node is going to be created in this case. Can you please confirm everyone? Is this concept is clear for you people, friends? Please respond, everyone. Is the concept is clear for you people, friends? I request everyone to please respond. Right, sir. Now I want to execute this code. Let us cross check whether this data is added or not. Sir, is the data is added? Yes, 111, 222, 333, 444. Perfectly in which order we have added? In the same order we got. Sir, same style. I want to implement one more method. In the same style, I want to implement one more method, which is nothing but void add last. Same, it will take a data object, and I want to create a new node. New node is equal to, so new node of, I am taking data field, so null field, null field. Yes, a new node object got created. Suppose if your head is equal to null, then your head will become new node because that is the newly created node. Suppose if there is already head node is there, pointers are same. Okay, pointers are same, but you have to traverse, right? So node, so current node will become head node. So until your current node next field is not equal to null, then what we have to do? So your current node is equal to, so your current node dot next, keep on moving to the ending. Later, so your current node next pointer is pointing to new node, and so new node previous pointer is pointing to the current node. That's all, sir. So I will explain with an example. Have a look once. Consider I have already some nodes are there. Otherwise, head is equal to initially null. We don't have any node now. So I want to insert triple one. This is nothing but consider a new node. So I want to insert triple one. This is nothing but new node what I have. Sir, is head is equal to null? Is head is equal to null? Yes, head is equal to null. So what it is going to do? Head will become new node. This will become head. This will become head, and this head will be gone. Now I want to insert one more, add at last. Sir, I'm creating a new node here. I'm creating a new node here. This will become new node. Okay. And now it is not new node. So consider its value is nothing but 322. Next field is null. Previous field is null. And here also previous field is null. Next field is null. Now listen carefully. Sir, is head is equal to null? No. Then new node will become current node. Sorry, current node is equal to head. So this will pointing to current node. Okay, this will pointing to current node. So this is pointing to the current node. Sir, current node tends to next is not equal to null. Sir, current node next field null, right? That means this condition is not satisfied. Then current node next field is equal to new node. Current node next field is nothing but new. Similarly, new node previous field is nothing but current. Like this we have maintained. Sir, consider I have these two nodes are there. Okay, this is nothing but I have triple one. Okay, and one more node is there like this. So this is nothing but triple two. Next node is null. This previous is nothing but this one, and this one is null, and this node is nothing but head node. Now I want to create a new node. Add last, right? It will be always adding at last. Consider its value is a 333. What is the name of this node? It will become new node. Next field is null. Previous field is null. Now listen carefully. Sir, is head is equal to null? No. So then node current node is equal to head. This node will become current node. This node will become current. Current node next field. That means this one. Is it equal to null? No, it is not equal to null. Then current node is equal to current node tends to next. Now this will become current. Sir, is current node next field is not equal to null? No, it is null, right? So that's why, so it will come out from the loop. Current node next field is equal to new node. Current node next field will become new node. And new node previous field will become current node. That's all. Like that objects will be added. Sir, can you please cross check? So in the place of add first, let me take add last. Okay. So I want to do add last. Consider same example. So first I want to add triple one. Okay. I want to add last. Sir, is it added at last? Yes. So it is added at last. You can able to cross check. Now, so list dot add last of, I want to add, what is the second node that we have inserted? Triple two. Let me run. Is it added at last? Yes, perfectly. Now So list dot add last of, I want to add 333. Is it added? Yes. So like this, we can perform which operation? Add last one. Okay. So I hope you people got very clear clarity about add first and add last methods. Okay. So DLL add first. So DLL add last. Sir, can you please confirm? Do you have any doubts about this add last method, everyone? Is it clear, everyone? I request everyone to please respond. Requesting everyone to please respond, sir. Clear, right? Now, sir, what is the next one? Add first, add last completed. So add first, add last completed. We know very well about this. Now, sir, inserting the data at a specified position. Okay. So means what? Void add. Okay. Add at a specific position. Like this, I am taking integer data. We have to provide the position also. Sir, I am taking I is equal to 0 because we have to count the position. So if your position is less than 0 or if your position is greater than or equal to size. So means what? More than one element is, if the position exceeds that particular limit, then we are going to print the message saying out of range and then return the control. Sir, otherwise create a new node like this with the data. Next field is nothing but null, previous field is also null. Then suppose if head is equal to null, then what we are doing? So we have to change. So your head will become new node, then immediately return the control. Okay, sir, my head is not equal to null. Okay, my head is not equal to null. So if your head is not equal to null, then check the condition. What is that condition? Sir, is position is not equal to 0. Because if position is equal to 0, what will happen? Again, so you have to insert at beginning, right? So consider if position is 0. That means what? We are inserting at beginning location. Sir, we have seen already how to insert at beginning. Suppose if you have a list like this one and here 2. Okay, here we have 1, we have next field as a 2. Okay, so next field as a 3. So next field as null and this previous field also null. Like this, if you have, then what we are going to do? So we have to create a new node at 0th position. Here I want to create a new node. Consider it is 9. This will become head node, right? So what we have to do? This will become new node. Already we know instructions. So your new node next field will become head node, right? And your head node previous field will become new node. Okay, then your head node will become new node. This instruction already we have seen. Inserting at first. Sir, if a position is not equal to 0, what we have to do? Sir, we have to traverse. So till to reach that particular position. So current node will become head node and I need some temporary node which is always null. So while current node dot next field is not equal to null, at the same time, if I value is less than position, so then your temp will become current node and your current node will become next node. That is nothing but a current node dot next and I plus plus. Now here the situation will come. So after traversing at last term, temp dot next is equal to new node. So new node dot previous will become temp. So new node dot next will become current node. Current node dot previous will become new node. Like this you have to take. Anyway, I will explain. Sir, already I have covered this code. That's why I'm not explaining. I'm concentrating on this position. Now consider listen carefully with respect to diagram I'm taking. Already I have some are there, like this is nothing but 1. So next field is nothing but something like 3. So next field is nothing but I have 5. So next field is nothing but I have something like 7. Next field is null. Previous field is nothing but this one. Previous field is nothing but this one. Previous field is nothing but this one. Next field is null. So I want to insert at a position 0, 1, 2, 2. In the second position, I want to insert the data called 4. Is position is position is equal to 2. Is it less than 0? No. What is the size? 4 elements. Is position is greater? No. Then create a new node. Okay. Anyway, I know here it will be created. So that's why I'm taking here itself. New node. Better I will change the color to understand clearly. So I'm creating a new node here. Okay. So what is the content? 4 is the content. This node name is nothing but new node, and the previous field is null. Next field is null. Now observe carefully what is going to be happen. So is head is equal to null. This is my head pointer, right? Is it null? No. Then is position is not equal to 0? Yes. Then current node is equal to head. This will become current node. Fine. Then temp is equal to null. What is the initial value of I? It is 0. Consider I value is equal to 0. Now observe carefully. Sir, is current next field is not equal to null? This is the current node. Next field is not equal to null. Correct. And I less than position, 0 less than 2. Yes, true. That means what? Temp will become current. This will become temporary node. This will become temporary node. And current node is equal to current node tends to next. Now this will become current. Sir, I think you got clarity why I have changed this one. Because previous node I am holding, next node I am pointing. Why? Because if you want to insert in this gap, okay, this node next field, this node previous field we have to capture. That's the reason. So I plus plus. Now I value will become 1. While current node is this one. Sir, is next field is not equal to null? Yes. I less than position. Is 1 less than 2? Perfectly working, sir. Temp will become current. Now this will become temporary node. This will become temporary node. Then current node will become current node tends to next. This will become what? Current node. Like this we have. Now, sir, I plus plus. Now I value will become 2. Next current node next field is not equal to null. Yes, really it is not equal to null. But I less than position, false. That means we came to the correct position to insert. Now observe these 4 pointers. It is very easy to understand. Temp tends to next will become new. This is a temp, right? This next field is nothing but next node. Okay. Then, sir, new node tends to previous is equal to temp. This is the new node, right? This is the new node, right? New node previous is equal to temp. Perfect. Still 2 more links are there. New node next field will become current. So new node next field will become current. Sir, current node previous will become new node. Current node previous will become new. Like this, you have to change, sir. So by default, this data is inserted or not? Yes. Sir, if it is clear for you people, I will execute this code and I will show you. Can you please confirm? Is the concept is clear for you people? Everyone, please respond. Clear, everyone? Right. Now I will execute this code. Now see what will happen. Assume add last of 111. I am taking 333. So I am taking 555. So list dot add last of, I am taking 777. Like this, I have some items are there. So if you print the list, we are getting something like this. Sir, in between this, I want to insert the node 9. Okay, in between this, I want to insert the node 9. Sir, let us see here list dot. Okay, so list dot add position of I want to insert 999 at 0th position. After this, I want to traverse the list. Sir, will it works? Okay, will it works? Let me cross check. Sir, are you seeing that 999 got added at first, right? Yes, perfectly it got added. Now, sir, I want to add it at first position. I want to add at first position. Is it added? Yes. Sir, I want to add at second position. Sir, is it added at second place? Yes. 0, 1, 2. I want to add at third place. Yes. Sir, I want to add at fourth place. Sir, out of range because 0th position, first position, second position, third position. So position 4 is not there. That's why out of range we got remaining elements. So I think how you can able to work with these, it is very clear for you people, guys. Right? Any doubts up to this, friends? Please confirm everyone. Any doubts up to this, friends? Please confirm everyone. Now, so let us go for the next type of insertion, sorted insertion. Sorted insertion we will see. What function we have to take for sorted insertion? Void sorted insert ascending order I will take integer data. Sir, it is same like insertion. Node, I am creating a new node is equal to, so new node of data field. Next one is null, next one is null. Then we need some current node is equal to head. First, I will check if the head node, that is current node, is equal to null. If current node is equal to null, then the node which you have inserted will become head node and we have to return the content. Otherwise, we have to check some condition. What is that condition? If current node dot data, that means if the first data is greater than the data, means what we have to do. So new node dot next will become head. So head dot previous will become new node. Anyway, I will explain this code, don't worry. So your head will become new node and then you have to return. Sir, when this particular thing is going to be happen, consider already some node is there. So 222. Next node is nothing but 333. Next node is nothing but 344. Like this we have next field is anyway null. Sir, now I want to insert the node at 311. 311 means definitely we know it will come in the beginning. It will become new node. And this is nothing but a head. Sir, current node head is not equal to null, right? Head is equal to null? No. Current node data. Current node is nothing but this one. Its data is 322. Is it greater than 311? Yes. Then new node tends to next will become head node. Head node tends to previous will become new node. Then this will be gone and this will become head node. That is a simple thing, sir, what we have. Sir, if this condition is failed, then what we have to do? Sir, we have to write a while loop to traverse the control. Current node next field is not equal to null. Okay. At the same time, so current node next field data should be less than our data. So till that, so you have to move current node is equal to current node dot next. Keep on moving the current until last. Sir, after this, what we have to do? You need to cross check. Is current node next field is not equal to null, means then we have to write certain code. If a current node next field is null, means we have to write some code. I will explain why we have to take these two blocks. Only because of double linked list we have these things, sir. Okay, otherwise unnecessary exceptions we are going to get, null pointer exceptions. So if it is the case, then new node 4 pointers we have to take. New node next field will become, so current node next field. Okay, so current node next field previous field will become new node. Then so current node next field will become new node. So new node previous field will become current node. Let me check how it is going to work. I explained already this case, right? Directly I'm going for this while loop, something like this. Now listen carefully. So consider already some data is there where this is nothing but a first node, or this is nothing but a first node what I have. So content is a 111. Next field is this, next previous field is there. So this is nothing but a 222. So next field is nothing but this one. Next field is nothing but this one. Like this we have null, and here we have 555, and here we have 333. So now I want to insert a new node. This will become what? Head node. So I want to insert a new node. Content is 444. So because I know it is going to be added here. This will become new node. One second. Now see here, sir. Second. Yeah, sir, which one is nothing but a current node here? This one will become current. So what is the data? 444. These fields are nothing but null. Now, sir, current node data 311. Is it greater than this data? No, condition false. So that's why while current node next field, current node is this one, next field is not equal to null. Yes. And the current node next field's data, that is 322, is it less than 344? Yes. Then both conditions are satisfied. Current node will become current node next. This will become current node now. Okay. Now, sir, current node next is not equal to null. Current node next data 333. So is it less than 344? Yes. Then what will happen? Sir, we are going to move current node here. Now current node next field is not equal to null. Current node next field data is 355. So is it less than 344? No, condition not satisfied. Now listen carefully. It will come out from this loop. Current node next field is not equal to null. This is the current node. Next field is not equal to null. Because if next field is null, that means if it is the last item, then you can't fetch previous all these things on these pointers, right? That's why separate code. I will explain that part also. Sir, now next field is not equal to null. Now what happens? Sir, new node tends to next. This is the new node. New node tends to next is nothing but current node next. Current node next is this one. New node next will become this one. So current node next is this one, tends to previous. That means this previous will become new node. Then Current node next will become new node. Current node next node will become new node. New node previous will become current. Like this we have changed. Suppose consider I want to insert a node at the last. I want to insert node at the last. Consider this will become new node. Then what will happen? Sir, current node will come up to here, right? Okay. Sir, current node next is null. It will come out from this node. Is current node next field is not equal to null? No, current node next field is null. That means previous links won't be there. Only next links we have to change. Current node next is equal to new node. Current node next node is equal to new node. New node previous will become current. That's all. Only these two links we have to write. When, if the next node is empty. If next node is not empty, we have to change these 4 pointers. Remember this. This is happens only for double linked list. If it is a single linked list, not required. Sir, I hope you people got very clear clarity about this sorted insertion in ascending order. Can you please confirm? Is it clear up to this? Sir, clear up to this? Please confirm everyone. Now, sir, if you have written for sorted insertion in ascending order, same process will be there for descending order, right? What thing we have to take? You need to take DESE, and here in the place of greater than, less than. So here in the place of less than, greater than, everything will become same. Now I am writing driver code. Listen carefully. So list dot sorted insertion ascending order of 555. So list dot sorted insertion order ascending order of 311. Let us see these two are added in according to the order. Yes, 311, 355. Now list dot sorted insertion of ascending order of 399. Is it added at the ending? Yes. Now list dot sorted insertion ascending order of 666. Will it added after 355? Yes. Now I am taking list dot sorted insertion order of 222. Sir, is it added at specified position? Yes. Now I want to add 333. List dot sorted insertion order of 444. Sir, is it added at specific position? Yes. Now I need to work with the descending. Sorted insert DESE. Now see, same output in the descending order we have to get. Came or not? Yes. This is nothing but how you can apply this sorted insertion ascending order and descending order. Even traversing also I completed. Can you please confirm, is the concept is clear for you people? I request everyone to please respond. Is it clear for you people? Yeah. So we have seen traverse function, add first, add last, add position, sorted insertion in ascending order, sorted insertion in descending order we have seen. Now, sir, anyway, that two functions are very easy functions. That's why first let me implement those two functions. What is that two functions? So size or length of the list. How you can able to get length of the list or size of the list? Very simple. You can take return type as integer, get size function I am taking. Okay, what it is going to return? The current object size it is going to return. Okay, next, and after that I want to implement one more function called search. Okay, so I want to implement one more function called search, which will take a data field and it is going to check whether that particular data field is existed or not. Sir, how you can able to check? So we are not required to concentrate on double linked list program. Whatever code we have taken for single linked list, same code. See, where the previous link and the next link you have to concentrate. Link establishment we have to do only at the time of creating a new node and at the time of deleting the nodes. Okay, in the remaining cases, we are not required to do any alterations. That's why for searching operation, is there any need to remove the data? No. Is there any need to create the data nodes? No. That's why we are not required to go with in detail. Just we can take temp head while this temp is not equal to null. One by one node data we have to check. Sir, if see, it is a search operation, right? That's why if temp tends to data is some temp dot data is equal to data, means what? Our search is successful. Just I am going to return true. If not, if that temporary node data is not equal to this one, then what will happen? As usual, temp will become temp dot next. That's all. At last, what we have to do, sir, return false, which indicates that the search is unsuccessful. Like this we have to do. Okay, just I implemented get size function and then search function. Beyond that, nothing. Let me execute up to this. Anyway, already we have inserted some elements. Now my requirement is I want to get the size of the list dot get size. How many elements are there? 1 2 3 4 5 6 elements are there. My expected answer is 6. Let us execute. You can able to see I have 6 elements are there. Similarly, I want to search for a data. For example, consider I want to search for the element called 666. Is the element 666 is existed? Yes. So hence the output what we are getting is nothing but 2. Is it correct? Yes. So I want to search for 777. Is the 777 data is there? No. Then if you ask the same function by passing 777 as the argument, the output what we are getting is nothing but false, sir. But once if you run the program, you can able to see we got false. So I hope you people got very clear clarity about this, sir. Can you please confirm? Do you have any doubt in this get size and then search functions? Please confirm everyone. Right, sir. So we have completed these two. Now, sir, it's time to talk about deleting from first. I want to delete the elements from first. Similarly, I want to delete the elements from last. Similarly, I want to delete the elements from a specific position. Sir, I don't know what happening. Remaining people, are you people are there or not? Because see, when I'm taking the class, if one or two students are responding, then it is not correct. So only Lingaraj Patil, Vishal, okay, Swapnil, um, Bhuyan, only these people are responding. So remaining people, I think better you can leave the session. There is no need to stay, right? Is it clear for everyone? Please confirm. Right. Now, so the next one, I want to implement deletion of the elements. Sir, I want to delete the items. How you can able to delete? Here you can able to see, I'm going to implement first, delete first. Void, what is the function name? Delete first I am taking. I think here it is not required to receive any parameter. Suppose if your head is equal to null, that means my list is nothing but empty, right? System dot out dot println of I am taking So double linked list is empty. Then you can return. Suppose if head is not equal to null, size minus minus. Because first node only we have to delete. Now what will be your head? Your head will become head tends to next. Okay, your head will become head tends to next. And compulsory you have to check whether head is not equal to null or not. Suppose if your head is not equal to null, then only you have to set your previous field as null. Listen carefully how it is going to work. Sir, here if you check, I have only one node is there. Okay, only one node is there. This is nothing but the head, and the previous field is null. Next field is null. Then this data is nothing but assume 7. I want to delete from this node, from this list. Is head is equal to null? No. Then size minus minus. Size is already 1. It will be decremented to 0. Now head is equal to head tends to next. What is a head tends to next? Null. Now onwards your head will become null. So it will check if head is not equal to null, but here head is equal to null. Because of this statement is not going to execute. Okay. Sir, next, when this line is going to execute, observe carefully. Suppose consider I have a list. Okay. So I have a list. So this is nothing but the data what we have. And this is nothing but the next data what we have. This is null. This is a 2 and this is null. So this one next field is nothing but this one. This one previous field is nothing but this one. This one is null. And this node will become which node, sir? Head node. Now observe carefully. I want to delete first. Is head is equal to null? No. Size minus minus. In this case, what is the size? 2 minus minus means 1. Head is equal to head tends to next. Now head is pointing to this particular node. If head is not equal to null, is head is equal to null? No, not equal to null. Then, so head tends to previous will become null. Head tends to previous will become null because anyway this one is gone because this node got deleted. Okay, if you delete this previous field, this one will become null and this one will become null. That's all. Okay, but in the case of single linked list, we are not required to write these 2 lines of code. This is the extra thing what we have. Okay, so I hope how you can able to perform. So deletion at last, it is very deletion at first, it is very clear for people. I think so. Can you please confirm? Is this concept is clear for you people, guys? Right. So I will go with deletion with last, sir. That means I want to delete the element at last. How you can able to delete? Have a look once. So what is the function name that we have to take? Void delete last. Okay. So how you can able to delete? How you can able to delete? Now you can able to see. So delete last means first as usual condition is head is equal to null or not. So if head is equal to null, system dot out dot println of double linked list is empty. Like this I am taking. Then you have to return. Otherwise, if your head dot next is equal to null, okay, if your head dot next is equal to null, that means so this is the last node. Next node is not there. Then we have to delete this node, right? Then immediately your head will become null and then size minus minus and then return. That's all. Otherwise, that means if head is equal to head dot next is not equal to null, head is also null. Not head is also not equal to null. That means we have huge number of elements are there. Then anyway decrement is mandatory. Then to traverse we need some nodes like temp node is equal to. Otherwise, I will take so temp 1 is equal to head. Okay, then temp 2 is equal to I am taking head dot next. Okay, 2 nodes I am maintaining. So while so temp 2, okay, while temp 2 next field is not equal to null. Sir, what activity we are doing? So temp 2 will become temp 2 dot next and your temp 1 will become temp 1 next. Like this we are maintaining 2 pointers. Okay, At last, what we have to do? You need to take, so temp dot next will become null. That is sufficient, I think so. But we will cross check. If anywhere something happens, then we will go with that previous field method. Okay. Now observe carefully. I have some nodes are there. Here, this is nothing but 1. And this next field is nothing but this one. And this next field is nothing but this one. And this next field is nothing but this one. And this field is null, and the previous field is this one. Previous field is nothing but this one. Previous field is nothing but this one. And this is the head node, right? Like this we have. Okay. Temp1 dot next, correct. Yeah, correct. Good. Now listen carefully what I am going to do now. Sir, here, if you observe very clearly, I want to delete the last one. Okay. Here you can able to see, is head is equal to null? No, sir. How many elements are there? 4. Is head is equal to null? No. Is head tends to next is equal to null? Because if head tends to next is equal to null, we have only one node is there. Then we are making head is equal to null, size minus minus. Sorry, but next node is there. So hence size minus minus. Anyway, we are going to decrement. Then temp1 is equal to head. This one will become what? Temp1. And temp2 will become this one. Now you got the point, right? So we have to move these locations one by one. Okay, sir, temp2 next is not equal to null. Temp2 next is not equal to null. Yes, then temp2 will become temp2 tends to next. Then temp1 is equal to temp1 tends to next. Like this we have. This is a temp1, this is a temp2. Since it is a loop, temp2 next is not equal to null. Yes, temp2 next is not equal to null. So move temp2 to here. This will be gone. Okay, and temp1 will become temp1 tends to next. Like this we have. So next temp2 dot next, temp2 next is null. So it will come out from while loop. Very simple. Temp1 dot next is equal to null. Temp1 dot next will become null, so that this field is going to be null. So automatically this will be gone. So remember carefully, we are not required to concentrate on this link, because once if this node itself is deleted, previous is not required because next field is null. Suppose if any such type of situation happened here, then you need to concentrate on previous. Okay, so I think in the case of delete last, previous method never required. But in the case of deletion of first, this node will be deleted. This previous link is there that we have to destroy. When you take the last one, so this previous node is there, but this node itself is going to die. No need to cross check. Okay. Now, sir, deletion at position we have to implement. But before moving to this, can you please confirm? Is it clear, friends, up to this? Clear? Sir, last node is having link to previous node. How it is going to be garbage collected? See, garbage collector nodes will be there, but when it is going to be happened, I think even if you see this, you can take this node name is nothing but a temp to, right? If you want, you can take a temp to next field, temp to previous field is null. See what I'm explaining. Maybe you are not getting. Okay, no problem. See here. Here, this is the first node what I have. So this first node, previous field anyway null will be there. Next field is pointing here. Okay. For this node, previous is nothing but this one. Next node is nothing but this one. And for this previous node is this one. Next field is null. If you want to delete this particular node, okay, if you want to delete this particular node, so what we have to do? You can delete this node. Okay, you can delete this node. We are making this one as empty. This link will be removed. Okay, so suppose head is equal to head tends to next, like that. If you take, so automatically it is going to be moved here. And this previous field compulsory you have to set it as a null, because this link is existed, this node is there. Okay, but after this we don't have any, and this is the last. So if you, how this node is referred? By using next to this one. But previous to this node, are you talking? No, because this node is not there. But in this case, previous to node is there or not? Yes, null node you have to take. That's why in this case, deletion of a previous link is mandatory. But here, deletion of a previous link is optional. Even if you take, no problem. But once if this link is gone, no one is going to ask about this node. Yeah, always we are talking about what is the previous to this node, what is the next to this node, that's all. Okay, but in this case, if you delete this node, compulsory this node previous link they are going to ask. In such cases, previous field is important. Clear answer? Not in all cases, only in one or two cases. Okay. Right. T2 tends to data. T2 tends to data. What is the need for T2's data? See, only for searching operation and only for what you can call insert operation. Okay. In such cases only we required and we need to concentrate on data. In the remaining cases, I think data is not required. T2's data will become 4 only, right? No, we are not required. See, we have to concentrate on our logical parts. So to ensure that node is deleted or not means at the time of printing only we will get, right? At the time of printing, what will happen? So first this will become temp node or current node. So is it next field is not equal to null or not? We will check. Next field is not equal to null means 1. So next it will go to here. So it's data next field. This field is there or not? Yes, print that. Next temp will become here, print that. So next tense is nothing but temp is pointing to null. Then it will stop. Anyway, it will be deleted. Okay. I will show you in the program. Right, sir. At least let me check this delete first, delete last. Is it working perfectly or not? Sir, I am going for add last method. Okay. So by adding 111. Okay. Next list dot add last of, I want to add 222. Okay. Next. So list dot add last of I need to take a 333. So list dot add last of, I need to take a 444. So list dot add last of, I need to take a 555. Like that we have. So traverse function, if you take, then what will happen? It is going to list out all the elements. Now let me check at least the basic. Yes. Now I need to, okay, I need to check system.out.println of, I think not required. Directly we can take. So list dot delete first we have to check. Sir, now list dot traverse. So after deleting, what will be the items we are going to check? Now let us check. Sir, what is the first element here? 311. That 311 gone or not? Yes. Sir, can I check delete last? What is the last node? 355. That is gone. Like this, delete operation is going to work. Sir, okay, fine. What about the next function? The next function what we have here is delete first, delete last is okay. Delete from a position. I want to delete from a specific position. So what is the function name that we have to take? Void delete, okay, delete element. So from position, otherwise at some position. So here I am going to give the position value. You have to check. So as usual, I will take some temporary node which is pointing to head because we need to move to that position. And I will take temp, one more variable temp. Otherwise, let us take it as a temp2, and this one will become temp1. Like this, I am taking. Next, what we have to do? Integer. To count that position, we will start from 0. And if temp1 is equal to null, that means what? If head is equal to null, just we have to print because that element is not there, right? Elements are not there. So double linked list is empty. Then we are going to return. Sir, if temp1 is not equal to null, and by mistake, if position is less than 0, or your position value is greater than or equal to get size. Get size. Otherwise, we can call size is there, right? Yes. Then what is the meaning? Sir, we are trying to delete the element which is not having the proper range. I am printing out of range. Then return the program. Else the problem will come. Sir, what is that problem? You have to check whether your position is equal to 0. If a position is equal to 0, we have to do certain job. Sir, what is that job? Your head will become head dot next. That's all right. You are moving head pointer to the next. And we have to check array boss whether head, okay, is not equal to null or not. If head is not equal to null, then head dot previous will become null. That means when we have only one node, that will happen. And size minus minus, and we have to return. Sir, it is something like, do you know, deletion at the beginning. Sir, otherwise what we have to do? We have to move to that particular position. Sir, how we are moving? While your temp dot next is not equal to null and I less than position. So we have to keep on moving, sir. Temp1 is not equal to null. Then what I am taking here, you have to check one more condition. If I is equal to position minus 1, that means if we have reached to the target, then we need to do certain operations. If it is not reached to target, I plus plus, and your temp1 will become, so temp1 dot next. Like this, we have keep on moving. I think not required to talk about these things. I will concentrate only on this file. Now listen carefully. I am taking the diagram also. Suppose consider I have some elements like this. This will become 11th element, I mean 11, and this will become something like 22. Okay, and this will become something like 33, and this one will become so 44, and this one will become 55. Like this we have. This field is null. and this field is null. So this is next, this is the previous, this is next, this is the previous. So this is next, this is previous. Listen carefully, it is somewhat difficult, sir. So 0th position, first position, second position, third position, fourth position. Assume I want to delete the data which is located at third position. Your position value will become 3 here. Now see, what variables we have assigned. Temp1 is always pointing to head node, right? Then where temp2 is pointing, temp2 is empty as of. Okay, sir, while temp1 is not temp1 next field is not equal to null, its next field is not equal to null. Okay, I less than position, what is the initial value of I? 0. Is 0 is less than 3? Yes, both the conditions satisfied. And so I is equal to position minus 1, I value is 0. Is it equal to position minus 1? No. Then I plus plus I will become 1. Okay, I will become 1. Then temp1 is equal to temp1 tends to next. Like this I am taking. Now again while loop, temp1 next field is not equal to null and I less than position. Yes, true. Then I is equal to position minus 1. No, false. Then I plus plus, now I will become 2. Okay, sir, next what will happen? Temp1 is equal to temp1 tends to next. Now sir, temp1 next is not equal to null. Yes, temp1 next is not equal to null. Is it I less than position? 2 less than 3. Yes, perfect. Then is I is equal to position minus 1? I value is what? 2. 2 is equal to 2. Yes, that means we came to the exact position. Now sir, we have to break these links and you need to change this link here. How you can able to do that is our main task here. Okay, now sir, temp1 dot next will become, so temp1 next field next, sir. Okay, sir, now listen carefully, I am taking. So if you take this one as a temp1 next field, temp1 next field is equal to, okay, temp1 next fields next field, temp1 next field will become temp1s to next fields next field. Like this we are taking. Okay, very good, very good. Now the next step what I am taking, listen carefully friends. So temp2 will become, so temp1 dot next. Sir, just now we have seen your temp1, okay, your temp1 next field link we have changed. That means now onwards, temp1 next field will become this one. So that will become temp. So this node is not having any name. That's why I have given the name as a temp. Now getting this previous will become very easy, right? That's why I am taking this. But make sure, suppose if you want to delete the element which is located at fourth location, please listen my points. If you want to delete the element which is located at fourth location, sir, fourth location next field will become null. On that null you can't call previous. That's why I am writing a small condition. What is that condition, sir? Here your temp2 will become, so temp2, okay, one second. So temp2 will become temp1 dot next. Okay, next field we got. Suppose if that temp2 is not equal to null, then what instruction I am taking? Your temp2 dot previous will become temp1. Suppose if last field is null, then you have to remove this. We can't apply this one. That's all. After doing this, definitely size minus minus and you can return the control. That's all, sir. Sir, will it works or not? We have to cross check. Really, is it going to work or not? Okay, sir, now what happens is its next field is not equal to null, right? That's why its previous field become this one and this entire node will be gone. That's all. Because of this one, we got these two instructions. Because of this double linked list, we got these two. Remaining things same, sir. Okay, and this one will become deletion at position. So delete at position is nothing but this one. Can you please confirm? Is this concept is clear for you people? Everyone, please confirm. Right. Let me execute this code. Right. So here dot delete element at a position of 0. In 0th location, which element is there, I want to remove. Have you observed? 111 gone. If you provide 1, sir, what output we are getting? The element located at first location, 222 is gone. Now I want to provide 2. The element which is located at a second location, 333 will be gone. Then I am taking 3. The element which is located at third location got removed. Now the element which is located at a fourth location, okay, got removed. Sir, can I give 5 here? No, because that position is not there. Sir, in such a case, what will happen? Out of range, because we have written already code, right? Like that it will work. Sir, okay, about deletion from position. Can I delete the element? Can I delete the element? That means what? I have content is there. If we have content, then how we can able to do? Okay, sir, it is also same like previous. Okay, I am taking void delete element of integer data. I am taking next, and after that node I will take some temporary node which is pointing to head, and then I am taking one more temporary variable temp2, and let us it will become temp1. So same like previous code only, right? So next what we have to do, if your temp is equal to null, that means what? So list is empty, system dot out dot println of, I am saying double linked list is empty, and then you can return. So temp1, sir, sorry. Next, sir, if temp dot data, that temp1 dot data, that means head node. So head node data is equal to data means the data which you are deleting is available at the first location. Then head will become, so head tends to next. Your head will become head tends to next. Suppose if your head is not equal to null, then what we have to do? You have to set a previous field to null. If it is a head, then we are not required to set, because we will get null pointer exception. Size minus minus and return. This is if the data is available at very beginning location. If the data is not available at the beginning location, then I am taking temp1 dot next is not equal to null. That means the loop which we have taken in the previous case. Okay, while temp1 is not equal to null, this position is not there. Just we have to keep on moving. How many times? If your temp1 dot next fields data is double equal to the data which you want to delete. Okay, suppose if the data is not matched, then temp1 will become, so temp1 dot next, like this we have to, and here I am going to take, so temp1 dot next will become, so already I explained, sir, that's why I'm not giving in detail. Temp1 dot next to next, then so temp2 will become, so temp1 dot next. So if your temp2 is not equal to null, if your temp2 is not equal to null, so temp2 previous field will become, so temp1. That's all. And we have to take a size minus minus and then read. That's all, sir. So beyond that, nothing. So it is going to delete the element. Let me check. Sir, I want to add last. So list dot add last of 666. List dot add last of 777. List dot add last of 888. List dot add last of 999. Like this I have. Okay. Let me give some duplicate elements. So 222. Okay, like this I am taking. Now delete element at a position. Delete element at a position. Sir, which position? Sorry, delete element. Sir, which element you want to remove? Consider I am taking 666. So is that element is removed or not? Let us cross check. Sir, 666. Previously 666 is there. Now that element got removed. Sir, can I give 222? If you give 222, it will delete the element available only at first occurrence. Rest of the things won't be removed. Why? Because you know very well. So we are going to return. Sir, I want to delete those elements also. In such cases, what we have to do? Sir, same code you need to take. I need to take delete elements. So if delete elements is there, then we should not return. Okay, we should not return. You have to check, there may be a possibility. Okay, and here also we should not return. We have to keep on checking, but at the time of checking, definitely here null pointer exception will come. So you need to write one more condition. Array boss, if temp1 next field is not equal to null, then only you have to move temp1 is equal to temp1 tends to next. Okay, only this modification. Now let us run. Really, is it going to delete? Only first occurrence got deleted. I think function name I have not changed. Now, sir, is it deleting all the occurrences? Yes, here 222 gone, 222 gone, 222 gone, like that. This is nothing but how you can able to perform. So deletion of element at first location, last location, position, deleting the elements, and deleting the element, and deleting the elements. Okay, so I hope you people got very clear clarity about this. Can you please confirm, friends? Do you have any doubts up to this? So in the last videos, we had a very clear discussion about okay, so double linked list. I think in these almost all the things we covered except reversing the list, right? So except reversing the list, so everything we have seen in the last videos. Now we need to implement this reverse function, and let us see how we can able to reverse. Okay, so here for doing this reverse operation, I'm not going for in detail implementation, because already we have covered that. Just I will take, okay, so normal implementation, not recursive, normal implementation I'm going to take. Observe carefully how it will be. So I think this program I'm taking as it is. Oh, I think we are doing in Eclipse IDE, right? Let's open that. Yeah, so I think up to this we have covered nth node from the ending. Now I need to implement which function? Reverse function. So once if you apply reverse, that entire linked list should be reversed. For example, consider I want to print this list. So list dot what is the function name that we have given? So traverse is the function, right? Yes, if you take, then the output is nothing but, so 111, next node will become 222, next node will become 333, next node will become 444, next node will become 555, next node will become 666, and last object will become null, right? Let us run up to this. Yes, we are saying like this. Now I need to reverse this. So what I am taking, double linked list, list one is equal to, So I'm going to take so new double linked list. Okay, I think object is also not required. Directly you can call reverse function. So what reverse function is going to do? It is going to reverse all the content present in this linked list so that your output should become 666 followed by 555 followed by 444 followed by 333 followed by 222 and then 111 and then last field is null. We have to implement in such a way that so we know the code very well. So node, I am taking some temporary node which is nothing but initially null, and I am taking current node which will become head node, that is nothing but the starting node. So while your current node is not equal to null, so what instructions we are taking? I am taking a temporary node will become so current node dot previous. I'm capturing the previous node, and your current node dot previous will become your current node dot next. Okay, and your current node dot next will become temporary node. Okay, then so your current node will become so current node dot previous. Like this we have to change the instructions. And finally, if your temp value is not equal to null, then your head will become temp dot previous. Anyway, I will show you how it is going to work. Listen carefully. Suppose consider I have a node like this. This is nothing but I have 111. Okay, so next node will become 222. So next node will become, since it is a double linked list, I am maintaining 2 pointers. And this node will become 333. Like this I have. Yes, it is sufficient. This node will become null, and this node, next node is nothing but this one. This node previous is nothing but this one. This node next field is this one, and the previous node is this one, and it is null. And what is the name of this node? It is nothing but head. Okay, current node is equal to head. Now I am maintaining this node name as a current. Sir, is current node is not equal to null? Yes, it is not equal to null. Then temp will become current node previous. What is the current node previous? Null, right? That will become temp. Listen carefully. Then current node previous will become current node next. Okay, so after this, what output we are expecting? So 333, like this we have, and then 222. Okay, like this we are going to get. Just for your understanding purpose I am taking, and this is nothing but 111. So what will happen? These links we are going to remove. How we are removing? Okay, temp will become current node previous. This is the current node, its previous field is null. That's why your temp will become null. And current node previous, previously it was null. Now I am making this one as a current node next. What is the current node next? 222, right? So that will become previous to 111. So previous to 111 will become current node next field, like this. Then current node next field will become temp. Current node next field will become temp. That means null. Like this we are maintaining. Then current node will become current node previous. What is the current node previous now? Already we have attached right triple. This will become current. Now, is it not equal to null? Yes, it is not equal to null. Now see what will happen. Temp will become current node previous. Temp will become current node previous. In this example, current node previous will become this one. So this is nothing but a temp. Listen my words. Now current node previous, this is the current node, its previous will become current node next. What is the current? 322. What is the next to this one? 333. Now current node previous will become this one. Then current node next will become temp. This is the current, right? Next field is what? So this is the current node, right? Next field is what? Temp. So 222 next field will become 111. Perfect. Now current node is equal to current node previous. Current previous is nothing but 333. This will become current. Again, is it not equal to null? Yes, it is not equal to null. then temp will become current node previous, which is nothing but this one. Now what will happen? Current node previous will become current node next. Current node previous means this previous will become current node next. That is nothing but null. Okay. Then current node next field will become temp. That is nothing but triple. And the current node will become current node previous. What is the current node previous? Already we have changed that. So it will become null. So your current node is pointing to null. So is current node is not equal to null? Yes, it is null. It will come out from this loop. If temp is not equal to null, temp is there. Okay, if temp is null means what? We have only one node is there. That will become reverse. So that's why I am not doing that operation. If temp is not equal to null, your head will become temp tends to previous. Okay, what is a temp tends to previous here? Okay, your temp tends to previous something. Temp will become current node previous. So head will become temp tends to previous. This node previous field is nothing but we have changed, right? That is nothing but 333, which will become head node. Okay, this is nothing but how we can able to implement. Okay, so I think you people got very clear clarity about how you can able to do this reverse operation. Sir, don't feel that here temp you have taken its previous field is nothing but this one. Don't assume that these links we have breaked, that one only we have understand here. So I have given the links here in blue color means what? These links are broken and node names as it is available, only that links I have changed. Okay, for getting better clarity. Okay, can you please confirm, is this a reverse function, how it is going to work? Is it clear for you people, guys? Please respond. Right, but I need to check, right, whether really is it working or not. We have to cross check really whether it is working or not. We have to cross check. Let me run the code. Sir, are you getting the reverse? Yes, perfectly. All the elements got reversed. This is nothing but how we can implement double linked list program. Okay, I think in the double linked list, what are the operations that we can able to perform? Everything we have finished, sir. Okay, so with this double linked list concept got completed. So I think with this you people got a clarity how we can work with connections, how to break that links, how to attach that links. Everything is clear for you. Can you please confirm, is it clear up to this? Please confirm, sir.